The second part of Lesson 3.5 focuses on graphing. We'll use factoring and synthetic divisions as means to find zeros. We'll state n behaviors, find our zeros, calculate our y-intercepts, and use those information pieces to sketch the graph of our functions. Please either print this template out in the folder on our Schoology page, or simply write this out on notebook paper. For each function below, state the end behavior. Then determine the zeros with multiplicities included. Calculate the y-intercept. Finally, sketch the graph of the function. For f of x equals 3x cubed minus 12x squared minus 15x, the first thing we're asked to do is state the end behavior. To do that, we need to know what the lead term is. So this is our first part, finding end behavior. The lead term is 3x cubed. That means this is an odd function because of the exponent being an odd number. 3 is positive, so that means a is greater than 0. Remember, our template for end behavior was as x goes towards negative infinity, that's an x, sorry about that. As x goes towards negative infinity, and as x goes towards positive infinity. What does our output do? If we think about our end behavior chart, an odd function with a positive lead coefficient, as x goes to negative infinity, y does the same thing. So you end up down in quadrant 3 on that left-hand side. That's a negative right there. And then on the right, as x goes towards positive infinity, so does y. And that ends up over in quadrant 1. That's our end behavior. Step 2, find the zeros and their multiplicities. To find the zeros, what we're going to do is set the equation equal to 0. 3x cubed minus 12x squared minus 15x equals 0. Now to try to solve this, we have a polynomial that's an x to the third power. If you look at all three terms, I notice there's a 3 and an x that they all have in common. If you factor out that common factor, we end up with x squared for that first term, minus 4x for the second term, minus 5 for the third term. And now we have a quadratic to try and factor. If the lead coefficient is 1, we want to split c to get that b coefficient in the middle. What are two numbers that multiply to get negative 5, but add to get negative 4? We could do negative 5 and positive 1. So we'd split the x squared into x times x. And if we have minus 5 and plus 1, negative 5 plus 1 would give us that negative 4 for the x in the middle. And negative 5 times 1 would get negative 5 for that constant at the end. Keep in mind we have 3x on the outside. That's all equal to 0. That's our factored form. Now we'll apply the zero product property and set each part, the first part, the second part, and the third part, equal to 0. If we set 3x equal to 0, and we divide by 3, x equals 0. That's easy enough. If we set x minus 5 equal to 0, and we add 5, we get another 0 at 5. If we set x plus 1 equal to 0, and we move 1 over, we get another unique x-intercept of negative 1. Notice all three of these didn't contain an exponent as their factor. There wasn't an x squared or an x cubed or an x to the fourth in each of those parts. That means all three of them have multiplicities of 1. And that's going to be useful for us when we graph. The third thing we need to find is the y-intercept. So we're going to calculate the y-intercept. Oh, and I'm getting an eraser for that. Hang on. There we go, y-intercept. To find the y-intercept of any function, plug in 0 for x. So this would be y equals 3 times 0 cubed minus 12 times 0 squared minus 15 times 0. Well, notice all of those terms are going to zero out if you're multiplying by 0. That means y equals 0. That's our y-intercept. All right, well, this is all the information we need. Finally, we're going to sketch our graph. To sketch the graph, we need to know all this key information from parts 1, 2, and 3. So to sketch the graph, I'm just going to do a very basic sketch. We're not going to get too particular about this. I know that I need to go a few places to the right. So I'll go 1, 2, 3, 4, 5, 6. I'll go 1, 2, 3, 4, 5. Go up 1, 2, 3, and 1, 2, 3. That should be all we need. All right, thinking about what this graph will look like. Since all three of our zeros had multiplicities of 1, we know that our zeros are going to cross the x-axis. So the zeros will cross over the x-axis. And we talked about that in the first part of the 3.5 video. Our end behavior, it said, as x goes towards negative infinity, so would y. That means on the left side we'll be down here in quadrant 3, and on the right side we'll end up somewhere in quadrant 1. Our zeros themselves, we know we have a 0 right at 0. We have a 0 at 5. I'm going to count over 1, 2, 3, 4, 5 on the right. And then at negative 1 on the left. Our y-intercept was also 0. So just make sure we are clear on that right in the middle. The sketch of this graph starts down in quadrant 3 and is going to go through the 3 zeros as it goes from left to right. That means we're going to come up through negative 1, turn, go down through 0 at some point, turn again, and go up through 5 over to the right. So there's a very rough sketch of our graph for this cubic function with the given zeros 0, 5, and negative 1. Let's try the next example. G of x equals x to the 4th minus x cubed minus 30x squared. This is an example of a quartic function. The first thing we're asked to do is describe that end behavior. To do that, we look at our lead term. Technically, that's 1x to the 4th. Now this is an even function. And we know that simply because the exponent is an even number. 1 is greater than 0, so it's positive. What this means for even functions, since arrows go in the same direction, as x goes towards negative infinity, and as x goes towards positive infinity, no matter what direction your graph is going, the end behavior for y is always going to be positive. The arrows will point up when we're done. That's step 1. Step 2, find the zeros, including multiplicities. To find the zeros, what we'll do is we'll set x to the 4th minus x cubed minus 30x squared equal to 0. Now look at each term. We have an x to the 4th, an x to the 3rd, and an x squared. The common factor here is actually that x squared value for x. We can take an x squared out of all three of those terms. For x to the 4th, we'd have x squared left over. X to the 3rd, if we factor out x squared, we'd have a plain x left over, or a linear term. If we factor x squared out of 30x squared, we have minus 30 left over. Now notice it's quadratic. And again, like that last problem, all we need to do is factor out or find two numbers that multiply to get positive 30, but add to get negative 1 in the middle. Keeping that x squared out in front, can you think of two numbers that would do that? Two numbers that multiply to get negative 30, but add to get negative 1? If you thought negative 6 and positive 5, that would work. That would give us negative 1 as a sum, but negative 30 as that product. And now if we set x squared equal to 0, x minus 6 equal to 0, and x plus 5 equal to 0, we'll find the zeros of our function. If we take the square root of 0, we get plain 0. But remember, this has to be including different or specific multiplicities. And here we have a multiplicity of 2. That's going to be significant for us when we graph. So let's write multiplicity, or just write mult of 2. And we'll have to work with that when we graph our function. For x minus 6, if we move 6 over by adding, we just get x equals positive 6. And if we move 5 over, we need to subtract, and we would get x equals negative 5. Neither of those factors had any exponents, so these would both have a multiplicity of 1. And again, that's significant when we sketch our graph. That was step 2. Step 3, find our y-intercept. If you plug in 0 for all 3 terms, you'd have 0 to the 4th power minus 0 cubed minus 30 times 0 squared. And that just equals 0 again. That's our y-intercept. So not all that exciting, is it? All right, last step. Let's put all this together and see if we can get the shape of our graph. To graph a quartic function with both arrows pointing up, it's going to kind of look like a W. So we'll say it looks like a W. It doesn't have to be a perfectly symmetrical W, but kind of a W shape. For our multiplicity of 2, it's going to be a turning point. Whoops, I don't even know what I'm trying to spell there. All right, it's going to be a turning point at x equals 0. So it'll just touch at that point and then go back in the opposite direction. It'll go through the x equals 6 and negative 5. So it'll cross over to the other side of our graph. All right, let's put all that information to the test and see what we get for our shape. We need to go over to positive 6 on the right. I'll count over 1, 2, 3, 4, 5, 6, 7, a little bit more. On the left, 1, 2, 3, 4, 5, 6. So we at least get to negative 5. Count up, 1, 2, 3. Oh, I'm going to redo that graph. Sorry, I don't like how the divisions are on the x-axis. Even though we're just doing a rough sketch, I'd like it to hopefully look a little bit more particular. Let's see if I can make that happen now. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay, a little bit better. We'll take it. Count up 1, 2, 3, down 1, 2, 3, even though we really don't plot anything on the y-axis for this one. All right, we know we have a multiplicity of 2 at 0. Make that a nice big 0 point there. Go over to positive 6, 1, 2, 3, 4, 5, 6 over here on the right, kind of. And then negative 5, 1, 2, 3, 4, 5 on the left. There's our zeros. Our y-intercept stays right in the middle. The y-intercept won't always be 0. It is just in this case. Now remember, we said our end behavior is going to open up on both sides. So on the left-hand side, it should be up towards the top. And on the right-hand side, it should be up towards the top. That means as we cross down through negative 5, remember we're going to go right through it. At some point, we need to turn. And as we turn and approach 0, that's a turning point. So it's going to touch at 0 and then go right back down. Turn again at some point and go up through x equals 6. I'll put my arrows at the top. So it's kind of an abstract looking W, but that's the general shape for this quartic function. The other kind of problems that we'll see look like the problems below. For each function, verify the factor using synthetic division. Use the quotient to find the remaining zeros by factoring or quadratic formula. Then determine the key features like the ones above and sketch each graph. Okay, so we've got our work cut out for us on these. Let's start on the left. P of x equals x cubed minus 52x minus 96. We want to first verify that x plus 6 is a factor using synthetic division. If x plus 6 is the factor, then we plug in x equals negative 6 into the penalty box. So I don't know, yeah, I'm not sure what's going on right there. Let's try that again. There we go. Okay, that's better. So I'm going to plug in negative 6 to the penalty box. And now look at our polynomial. I see we have an x cubed, but we're missing our x squared term before it goes to the x and the constant. That means we need 0 as a placeholder. In front of x cubed, the coefficient should be 1. Since x squared is missing, we need to put a 0 there. And then our constant, or our coefficient of negative 52 and negative 96. Wow, let's sure hope that this is a factor. Those are some big numbers to deal with. Give yourself a row of work and then draw your blue line. All right, let's put this to the test with synthetic division. Drop that first coefficient straight down. Anything below the blue line, multiply it to the penalty box. 1 times negative 6 gives us negative 6. If we add that column, 0 minus 6 would be negative 6 again. Multiply that with the penalty box. Negative 6 times negative 6 is positive 36. If we add the column now, we have negative 52 plus 36. That gives us a sum of negative 16. Wow, check this out, you guys. Negative 16 times negative 6 is in fact positive 96. So we get 0 as a remainder, and that verifies that x plus 6 is a factor. But now our quotient, we still have to do some work to. This should be one less degree, so that'll be 1x squared minus 6x minus 16. It says use the quotient to find the remaining zeros by factoring or quadratic formula. What this means is we have to set this equal to 0. Hopefully this is factorable. If we have x squared minus 6x minus 16, what are two numbers that multiply to get negative 16 but add to get negative 6 in the middle? Hopefully you recognize we could do x minus 8 and x plus 2. So that factored very well for us. If we set x minus 8 equal to 0 and we move 8 over, we would get x equals 8. If we set x plus 2 equal to 0 and move 2 over, we would get x equals negative 2. Those are the zeros of our function. Negative 6 from up above, positive 8, and negative 2. All right, what I'd like you to do right now is determine the key features and sketch the graph, and that will be your assignment for the Google Meet tomorrow. The key features are the end behavior, we already know the zeros with their multiplicities, the Y-intercept, and then see if you can sketch the graph. Tomorrow we'll finish the lesson with the h of x equation.